6.4, distance problems. So distance problems can be tricky, but they're also similar a little bit to age problems that you did in the last section. But because they're tricky, I've come up with a 4-step process that should help you, and it mimics what's done in the book also. So the first thing you need to know is the formula. Distance equals rate times time. And a lot of you already know this formula, okay? Or you've used it before, or you just kind of figure it out using probably something like this. Distance equals rate times time. Rate is referring to the speed. It's another word for speed. And the way I remember it is D equals RT. The lowercase r, lowercase t is typically how you see it, although I wrote it differently above here. And I call it the DIRT formula because it looks like it spells the word dirt. So I don't know if that helps you or not. So here's the steps. First, read the question and draw a simple picture. Second, use D equals RT and complete the chart. See the chart ready for us below. Third, write an equation and solve. Fourth, answer the question in a complete sentence. Definitely 3 and 4 are the same process as was done in the age problems, but the equation's going to be different in every problem. This one requires a picture, whereas the other one didn't. And this one has a formula, which the other one didn't have. So let's use the example and follow the steps. 2 frogs are touring the Scottish coast on orange Vespas. One of them travels 5 meters per second faster than the other. Several bored sheep clock the frogs riding for 8 seconds and calculate that they have traveled a combined distance of 184 meters. How fast is each frog going? So I'm going to draw a picture, and I said simple, and I mean simple. Here's frog 1 going this direction. Here's frog 2, probably going further. The reason frog 2 is going further is because it went faster. Now it says that they were both riding for 8 seconds. So that's an important piece of information. And they've traveled a combined distance of 184 meters. So that means when I look at the distance, this picture here, this is frog 1's distance, the whole thing. This is frog 2's distance. So combined distance would imply that you add them. And when you add them, you get 184 meters. That's important, making sense of the problem. So that's what I've done here. Sometimes I don't do the equation right away like this. Sometimes I just do a picture and think about the equation in step 3. But in this case, I felt like it was pretty easy to do that, so I did. Okay, so now we've drawn a picture. Now I can move on to step 2. Using the DIRT formula, complete the chart. So on the top, I write D equals R times T. Looks like dirt. On the side, I'm going to use the 2 things that we're talking about. We're talking about frog 1, F1, and frog 2, frog 2. So now it's all labeled. In the book, you'll notice that they put frog 1 and frog 2 at the top, and they put the DIRT formula on the side. Personally, I like the way it works better like this, but you are open to choose either way to do it because I think both are perfectly fine. So whichever makes better sense to your mind, you can do it that way. So now let's fill in what we know. 2 frogs are touring the Scottish coast. We've got our 2 frogs. One of them travels 5 meters per second faster than the other. Okay, so they're talking about rate. One of them travels 5 meters faster than the other. So let's just say I don't know the speed of frog 1, so I'll call that x. This one's going to be 5 meters faster, so it's x plus 5. Does that make sense? I hope so. Now it says several bored sheep clock the frogs riding for 8 seconds. Okay, 8 seconds. Well, that's going to be time. So I'm going to fill in an 8 under time, and they're both going for 8 seconds, so I'm going to list 8 in each frog's time. Now, before I go any further, I'm going to use my chart to fill out the rest. I know that R times T is going to give me D, so I'm going to actually multiply what's in the chart. 8 times X is 8X. 8 times X plus 5. And don't forget to use parentheses because you will have to distribute. 8 times X plus 5. Okay, I've completed my chart. Step 2 is done. Step 3, write an equation and solve. Well, let's go back to our picture. We said that the distance of frog 1 plus the distance of frog 2 is going to be 184 meters. And that uses my last bit of information from the problem. So what that looks like is I'm going to look at the distance of frog 1, which is found right here, and I'm going to write that, 8x. Plus my distance of frog 2, which is the one right below it, 8 times x plus 5. So that's frog 1's distance plus frog 2's distance equals 184 meters. Okay, I wrote my equation. Now I need to solve it. 8x plus, don't forget to distribute into the parentheses, 8x plus 40 equals 184. 8x plus 8x is 16x plus 40 equals 184. Subtract 40 on both sides. 16x equals 144. I'm running out of room here. Divide by 16. Divide by 16. X equals 9. Good. So now you feel like, oh, step 3, done. Now you feel like, okay, well, I'm done with the whole problem. Great, I can just move on to my next one. But no, you still have one more step left. And a lot of students just stop there. They think they're done. I got x equals 9, I'm done. But you're not done. Answer the question in a complete sentence. So what is it asking me for? How fast is each frog going? All right, well, I have x equals 9. What is x equals 9? We'll go back to your chart. X is right here. That's the rate of frog 1. So frog 1's going 9 meters per second. So frog 1 is traveling 9 meters per second. And frog 2 is traveling 9 plus 5, 14 meters per second. And now I am done. Okay, here we go again. Another question. Okay, I'm going to have to move this out of the way. Let's put it over here. 4-step process. Now we've got 2 turtles dancing. So this is the same list as before, so I'm just going to check it off as I go. 2 turtles are appearing on Dancing with the Stars. They both start at the same point and dance their way in opposite directions around the 106-meter circumference of a circle. Thomas Turtle can waltz at 8 meters per second. Tina Turtle can rumba at 8 meters per second, but she misses her cue and starts 2 seconds after Thomas. How far will each one have traveled before they run into each other? Okay, tough. So, draw a simple picture. They're dancing around the circumference of a circle. That's important. And it tells me what the circumference is. So you have to remember what circumference is. And if you're not sure, look it up. Dictionary, online, anywhere. Call Cindy, call friend. Circumference is the outside of a circle. So we've got Tina Turtle right here and Thomas Turtle right here because they start at the same point. And they dance their way in opposite directions. So this one goes around the circle this way. This one goes around the circle this way. And at some point, they're going to collide. So that's start. This is Tina. Tina, Mr. Q. So this one is going to be Tina because she's not going to make it as far. We're not sure, actually. And this side's Thomas. And it really doesn't matter how accurate the distances are because you're going to calculate them. So they start here. Thomas goes this way. Tina goes this way. Okay, so I drew a simple picture. And let's just say I don't want to figure out the equation yet. I'll think about that later. Okay, so now let's use D equals RT to complete the chart. So across the top, I write D equals R times T. I've got Thomas and I've got Tina. Okay, so 2 turtles are appearing on Dancing with the Stars. They both start at the same point and they dance in opposite directions around 106 meters circumference. Well, 106 meters is not going to help me just yet. So let's save that. Thomas can waltz at 8 meters per second. Thomas, rate 8. Tina can rumba at 10. Tina, rate 10. But she misses her cue and starts 2 seconds after Thomas. So that's tricky. We got to think about the time now. Thomas's time versus Tina's time. So 2 seconds after Thomas. So who's actually going longer? I think Thomas will be dancing longer. So you could do this one of two ways. I'm going to say that if Tina is dancing for X seconds, Thomas is dancing for X plus 2 seconds. The other version would be that Thomas is dancing for X seconds and Tina is dancing for 2 seconds less than Thomas. Either way would be fine. I prefer the positive way with a plus, so I'm going to use the black one. Okay, now before I continue, I use my chart, R times T. So I have 8 times X plus 2, and I have 10X. Okay, I've completed my chart. Write an equation and solve. So now I go back to my picture and I say, okay, here's Tina's distance, here's Thomas's distance, and they collide here. So by the time they collide, both of them together, that means Tina plus Thomas, are going to have traveled all the way around the circle. Tina plus Thomas make the whole circle, and the whole circle has 106 meter circumference. So Tina's distance plus Thomas's distance is 106 meters. So now I look at this column. Tina's distance plus Thomas's distance is 106. At 8 times x plus 2 plus 10x equals 106. Okay, now I solve. That is definitely the hardest part, is filling out the chart and writing the equation. So once you get over that hump, this part should feel easy. So I've got 18x plus 16 equals 106. I subtract 16. Over here I get 18x equals 90. Divide by 18, divide by 18. And I get x equals 5. So I've written the equation and I've solved, and now I need to answer in a complete sentence. So it's asking, how far will each one have traveled before they run into each other? So it's asking me for the distance. My x is 5. I put 5 into my distance here. Thomas traveled 8 times 5 plus 2 is 7. So that's going to be Thomas traveled 56 meters. Tina traveled 10 times 5, 50 meters around the circle, if you want to be really great. And both of those, of course, add up to 106, so that makes perfect sense. Okay, great. Done. Now let's go on to the next one. We've got one more. And if you feel like you can do this yourself, try this one, pause the video and try this one on your own. And then I'll go over it and hopefully you can see you did it right. Okay. On the way to Loch Ness, the messenger traveled at 100 miles per hour. He took it easy on the way back because he was disappointed that he did not see the monster, only traveling 90 miles per hour. The trip took 2 hours overall. How long did it take him to get to Loch Ness in the first place? So here he starts and he goes to Loch Ness at 100 miles an hour. Then he goes back home. Oh, interesting. So this is the way there, and this is the way home. And the distances to me look the same, which is very interesting. Equal is going to be important. So I've got distance equals rate times time. I've got there, and I've got home. On the way, the messenger travels at 100 miles an hour. On the way back, he travels at 90. What's the time, though? It says the trip took 2 hours overall. That means that these have to add up to 2. So that means I need to make one x and one 2 minus x, because whatever x is and this one have to add up to be 2. So that's how you would express it algebraically. Now I use the chart. 100x is right here. 90 times 2 minus x is here. And I've got my chart filled out. Now my equation, remember the distances are going to be equal. So I do one of the distances, 100x, equals the other distance, which is 90 times 2 minus x, and I solve. 100x equals 180 minus 90x. Add 90x to both sides. I get 190x equals 180. I divide by 190. And I'm going to get a decimal on this one. 18 over 19, which is less than 1. And I don't have a calculator. So let's leave it as a fraction. 18/19, and that's going to be hours. Probably best to divide here because it would make more sense to have that in a decimal. So the question is, how long did it take him to get to Loch Ness in the first place? That is exactly there. The time to get there is x, so that's my answer. And as I said, if I had a calculator, I would actually compute it, or I would do long division, but I don't want to take any more of your time. So good luck with this section. Ask for help if needed.